Okay, so today we're going to talk about the King's Rule and how you'd apply this in your exams. So first of all, let's prove that because it's easy. So obviously we start from the right hand side. So we'd have u equals a plus b minus x, du is negative dx, and then when x is a, u is b, when x is b, u is a, and then there's a negative sign, so we could write this. And after dummy variables, we'd have that. And that just proves the King's Rule right away. So now let's do some examples. Part A is wherever this integral is. So when you see this at the bottom, the obvious thing you'd do is you'd use a trig sub. So let's say x is tangent of theta, dx is wherever this is, and obviously we have the boundaries. So it's from 0 to pi over 4. These two cancel, so now we have this natural log function. After this natural log function, now we could use the King's Rule over here. So that's just double angle formula. Compound angle formula, sorry about that. Anyone would know how to use that. So this one becomes a fraction. And these are just ones. So now we have 1 plus tangent theta plus 1 minus tangent theta. So we'd have this fraction, which splits into two integrals. Oops, that should be a minus. And this is just whatever's up there. That equals to this really simple integral right here. Anyone will be able to do that. And this one, without the 2 times, is whatever we want. So we could just say that this is equal to 1 over 2 theta natural log 2 from 0 to pi over 4, which is pi over 8 natural log 2. That's part A. Very simple. Just apply King's Rule and you'd have your answer. Part B is also an obvious application of the King's Rule. Okay. Because and obviously we have the same thing here. This is because we are rotating the triangles by 90 degrees. Oops, sorry about that. We're rotating by 90 degrees, so sine becomes cosine, cosine becomes sine. Very basic stuff, not going to explain that here. So now, applying King's Rule, we'd have sine becomes cosine and cosine becomes sine. So we have the same thing. And then this one becomes cosine. And which is very funnily enough 1 minus the same thing we want. So 2 times of that dx is from 0 to power over 2 1 dx. Very funnily enough, this is true. So whatever we want is just 1 over 2 of x from 0 to pi over 2, which is just pi over 4. And that solves part B. It only takes like 4 steps and it's over. But if you want to do this without the King's rule, then it's up to you. But you can't really do that. You're forced to use that rule here. Part C is a little bit more tricky, but it's the same thing, practically speaking. So it's from 0 to 3 pi. Oh, sorry. Is that 1 plus sine x? Yes. Oops. Dx. And we could apply King's rule right away. And sine 3 pi minus x is sine pi minus x, which is sine x. And funnily enough, we have 2 times of whatever we want. It's 3 pi of 1 plus sine x at the bottom of sine x. So now is where it gets tricky, because it takes a little bit of by parts, I think. So this is actually quite a tricky one. But it's still doable, obviously. Very doable. So that's 1 minus 1 over 1 plus sine x. So that really doesn't help. So we have to gonna use some by parts. So differentiating this is well, let's finish this off first. So cosine 3 pi is negative 1 over 1 plus 3 pi. Sine 3 pi is 0. So negative 1 minus 1. So that's negative 2. So it's 3 pi. This one becomes negative 1 plus sine x squared, and then cos x. So now we'd have 0 to 3 pi of 1 plus sine x squared cos squared x dx, which is 1 minus 1 over here sine squared Oh, we don't really have to split that actually. My bad. So that's 1 plus 2 sine x plus sine squared x. And which is 1 plus 2 sine x plus 1 minus cos squared x. That really doesn't help either. We don't really need that. So now we have let's break this and then create a 1 minus situation. That's 1 plus 2 sine x plus sine squared x minus 2 sine x minus 2 sine squared x. Now we have 1 dx minus minus 2 sine x. So let's put the 2 out. So it's sine x 1 plus sine x. Yep, and then it's 1 plus sine x squared dx, cancelling out, and then we'll have the same thing we have here. Okay. So let's go ahead and do some calculations because we're almost there. This one is x from 0 to 3 pi, so that's 9 pi squared over 2 minus 3 pi of let's copy that down, dx, and this one realistically is just 3 pi over 2 of this. So we'd have 3 pi over 2 plus 3 pi. So 3 plus 3 over 2 is 9 over 2. 0 to 3 pi of 1 plus sine x dx is 3 pi plus 9 pi squared over 2. So and this thing 1 times is 2 over 9 pi. So 2 over 3 plus pi. It's not over because that's not the original integral. The original is 3 pi over 2 times of that. So the original is 3 pi over 2 times of whatever's there. So that's pi plus 3 pi squared over 2. And that's it for part C. So this King's rule really is to simplify some of the functions so you get easier integrals to deal with that you could do in your normal methods. And I hope this video helps. And that's it for today.